Alright, we're moving on to section 4 here in chapter 12. It's pretty much everything to do with areas of circles, and then a couple of new terminology here, sectors and segments. But basically what we're going to do here is, there's not a lot of new information. I'm just going to give you a couple of definitions and then run through a bunch of example problems, and we'll see where we're at. Of course, the whole thing is predicated around this concept of the area of a circle. And of course that is just pi r squared. A sector is just part of that. It's the piece of the pie, or the piece of the circle. And the area of the sector, of course, is the measure of the arc divided by 360, which is the fraction of the area of the entire circle, which should remind you of the the length of the arc formula, which is the measure of the arc divided by 360, or the fraction times the circumference. So this is just the fraction of the circle times the area of the circle. And so in a problem like this, where we have the angle measure here is going to be 120 degrees, and the radius is 12, and we're looking for the area of the sector. I'm just going to do 120 degrees divided by 360, or the fraction, which is 1/3 of the area of the circle, which we know is simply pi r squared. And so we know it's pi times 12 squared. And so it's 1/3 of 144 pi. Moving on to the second problem here, we're looking at the area of the shaded region, and that brings us to the second idea and the last idea, that new idea, and that is that this is called a segment. Not to be mistaken with the segment that we had earlier in the school year, and that we use all the time. Of course, for example, this radius is a segment, but this is the segment of a circle, and it's the shaded region there, where you basically take the area of the sector, which is the piece of the pie, and you subtract this area right here, which is the area of the triangle. That would be equal to the area of the segment. So if we're looking for that shaded region, we start with the area of a sector, which we just learned is the measure of the arc. In this case, the measure of the arc is 90, so it's going to be a right angle here. So we know it's 90 divided by 360, or 1/4 of the area of the entire circle. And we know that the area of the entire circle is 36 pi, because the radius is 6. And we're going to subtract the area of the triangle here. We know it's a right triangle with a radius of 6, and this side is 6, so we can just do 6 times 6 and divide that by 2. Base times height divided by 2. And simplify all this, I think we get like 9 pi minus 18. And just leave it in that form. That's an exact answer, which we like. Moving down the page, maybe we see a problem like number 5 here, which there's a couple of ways of approaching this one. I think the easiest way might be to kind of draw a radius right there and split this thing into 2 congruent triangles. We know they're congruent because these 2 arcs are congruent to each other, here and here. And we know that this angle ABC is 60, so we know that this angle down here is going to be 30 degrees. And I can draw in an altitude with the right angle here, and I'm going to get some 30, 60, 90 triangles going here. I know that the radius is 16, so I know that this is 16 right there. So if I go ahead and draw this triangle out here, what are we looking for? We're looking for the area of the shaded region. I'm just going to take one of these triangles and kind of just blow it up a little bit. And I know that this is 16, this is 30, got a 30, 60, 90 triangle. This is 90 degrees here, that makes this 8. And so this is going to be 8 root 3. And so we can find the area of this triangle here is just going to be 8 root 3 times 2, but divided by 2 times the height, which is 8, or 64 root 3, excuse me. And then that's going to give you the area of one of these triangles. So I need 2 of them, right? I have one triangle here. That's the area of, and I have 2 of them. So it's just going to be 128 root 3 as my answer. All right, let's flip over to the next page and let's take a look at some of the problems on the back. All right, moving on to the back side here, I see circle Q with a radius of 8. So I know I can do that this is 8 here. The length of the arc is 2 pi, so I know the measure of the arc divided by 360 times our circumference, which in this case we know is just going to be 16 pi. And that, of course, is going to be equal to the length of the arc, which is 2 pi. So let's solve for the measure of the arc. The pi's drop out. And when I solve for this measure of the arc, I'm going to end up with 45 degrees as my answer. So I know that that guy right there is going to be 45, even though it doesn't look like it is. And then the area of the sector from the first side, we know that the area of the sector is equal to the measure of the arc, which is 45 divided by 360, times the area of the entire circle. So it's 64 pi because the radius was 8. And that simplifies to 8, I believe 8 pi. Okay, let's move on to problem number 8. Okay, so we got a chord here. Its length is 10. Intercept a minor arc. And we're looking for the area of this right here. So we're looking for the segment. And I know that the diameter is 18, so I know if I draw in my little triangle here, I know that these two sides are going to be 9 and 9 right there. And looks like the length of the chord is 10, so if I draw in a radius, an altitude right here, I know that this side's going to be 5. I can find the altitude, let's call it x, by doing the Pythagorean theorem. I can do like x squared plus 5 squared equals 9 squared. And so x is going to end up being equal to 7.48. And looks like I'm going to have to do some trig here because I don't think that these numbers are going to all work out beautifully. So let's go ahead and do that. Let's change our color here. So if I make this angle here theta, I can do like the sine of theta is equal to the opposite side, which is 5, divided by the hypotenuse, which is 9. Do an inverse sine to get theta, which is 33.75. And so I know that the central angle is this entire angle right here is what we actually need to measure to find the measure of the arc. That's just 2 times theta, or 67.5 degrees. And now we're ready to go ahead and go after what we're looking for, which is the area of the segment, which is just going to be the area of the sector minus the area of the triangle. And so the area of the sector is just going to be, we know it's 67.5 divided by 360 times the area, which is just going to be 81 pi. And then we're going to subtract the area of this triangle right here. And so I can do 5 times 7.48, right? And so ultimately this simplifies, I believe, if I round it just to the 10th, 10.3 approximately. Okay, and then let's see if there's any other problems down here. Yeah, let's go after these two. The first one here, I mean, with some of these problems here, you just kind of have to think about it in more of a clever way. You can kind of, you know, you can look at this as, well, each of these right here are going to be, each of these guys are going to be 3/4 of a circle. So if I go ahead and do 3/4 of a circle, and the area of a circle is going to be, each of these this is 10, so that makes this radius 5, 25 pi. And I know I got 4 of them, so just multiply that by 4. So I end up with 75 pi. Same type of thing down here. I can look at this, I can try to brute force this thing, but what I'm going to do is I'm going to take the area of the big triangle and I'm going to subtract the area of, and if I think about it, it's this one plus this one plus this one. If it's an equilateral triangle, this is 60 degrees, 60 degrees, and 60 degrees. That adds up to 180 degrees. And if I combine all 3 of these little sectors together, I'm going to end up with a semicircle. So I'm just going to take the area of the big triangle, which this side is 6. So I know that this whole side is going to be 12. And so I can do 12 squared root 3 over 4, which is the area of an equilateral triangle, minus half of the area of a circle. So it's just going to be 36 pi. So I end up with, if I simplify this, I get 36 root 3 minus 18 pi. And that's it. Just, I think that's all the problems I wanted to run through, and I'm going to let you go ahead and try some of the problems in the book. All right, take care.